Yeah.
One second. दिख रही है screen?
हाँ.
हाँ दिख रही है.
Okay. So hello guys, myself Shalini, second year electrical engineering, and I am part of robotics club at IIT. So in the previous workshop we ended on masking. Did anyone try clock thing? Clock जो last में था, किसने try किया? हाँ ना बोल दो.
हाँ मतलब थोड़ा थोड़ा ट्राई कर रहे थे. फिर वो
वाह.
वीडियो इनपुट मतलब वो कैसे लें और उसे आउटपुट वो थोड़ा नहीं हो पाया.
अच्छा चलो और ट्राई करना, इस वर्कशॉप के बाद और ट्राई करना और अच्छे से आ जाएगा. हाँ तो you know by now that this is the HSV values, HSV respectively. So all the colors lying in this particular range will be given the value 1, which is equal to white, and the others will be given 0, which is black. Okay, I will show a quick code for this. Here I have an image pic and I have written the colors for red, blue and pink. Okay, let me run this. So this is your PS from Pixel 8 previous year. The Technics, it will be coming soon. Technics. So this is the PS screenshot. You have the pink mask here. You can see the pink color is only shown here, slight pink. Here blue, dark blue we have, and red. Okay, cool. Since we have already covered this, I will not be explaining it in detail, just going through it. Next we have color filtering. Like we have already done masking. Now we want to show that particular color on screen. For now we only have black and white, right? Now we will show that color over that white thing. So for that we use bitwise AND. So the arguments are, this shows the source image 1. This is the source image 2. The images we are going to use and apply the bitwise AND operator on. The third is mask. The mask we wrote here. You can get this more by the code. I have written it for pink. Here I have pink. I will comment this out. Run it. Okay. So this is the original image. This is the mask we created for pink, and this is pink. So you can easily use this code for showing a single particular color. Okay. Nice. Now this we did for only single color light. I will show you one more cool use for this. So as I told you, this is the source image 1, this is the source image 2, and we use the same image here because we wanted to just mask that single image. But here I am using two different images. Let's first see the result. Okay, here this is the first image. This is your PS for iMaze. We had like similar to La Robo Liga. For you, we had this. So now when we combine both of them, we have this image. And you see bitwise AND operator. So the pixels, white pixel and the gray pixel, when combined it shows gray pixel here, and similarly for other pixels the AND operator is applied. So now you can clearly see the use of AND. I haven't applied any masking here. I didn't write a mask code, so I wrote here mask equals to none. Okay, let's get back to it. Next we have morphological
दीदी
transformation. हाँ.
एंड मतलब होता क्या है एक्चुअली. मतलब RGB वैल्यूज ऐड होते हैं या फिर
हाँ
मीन
ऐड
ऐसा कुछ होता है क्या?
नहीं ऐड होते हैं. जैसे तुम्हारा मान लो इधर वाइट है, वाइट के साथ एक और इमेज है जिसमें ग्रीन है, तो ग्रीन वाइट प्लस ग्रीन ग्रीन हो जाएगा. मतलब जो वैल्यूज है ना 0, 20, 55 वो ऐड हो जाएंगी.
अच्छा ओके.
कुछ और डाउट एनीवन? हैं Okay, next we have morphological operations. So this is basically you have an image. Let's suppose I will use this image. Okay, you have this image and these are the pixels defined. So like एक इमेज सिर्फ ब्लैक एंड वाइट है तो कहाँ कहीं कहीं पे जीरो विच मीन्स इट इज ब्लैक एंड द रेस्ट इज वाइट. Okay, so what morphological operations does is it compares the pixel neighboring pixel, like you take 0, it compares to the neighboring one and gives output based on that. We have different morphological operations like erosion and dilation. We are discussing two here. So in erosion what happens is imagine you have an image and there is a, like I will explain from this. You have an image, this is the erosion result. So we have an image having 0 0 1 1 1. So what is this, it compares the close one, if it sees 1 it converts it into 0, and for dilation if it sees 1 close it converts the other two to 1. So you can see in an erosion image you will see more of black, in a dilation image you will see more of white. Now let's get into the code. We need a kernel for this. One is the image we want to apply erosion and dilation. Next is kernel. Kernel is a matrix. Here we are taking 5 cos 5 matrix. So in here, this is not for 5 cos 5, but I will explain just using this. So let's take a 5 cross 5 matrix here, and if it sees a single one there, it will convert all of it to 0. In erosion it will convert all of it to 0, and in dilation it will just do the opposite, it will convert it into 1. Okay, but here it's I guess 2 cross 2. I guess the matrix here is 2 cross 2. You will find that out. Okay, let's see the code for morpho. See this, we have this image and it compared the nearby pixels and turned them to 0. So we see more of white and more of black and less of white. The lines have thinned out here. Okay, do you see the difference? Now for dilation, I have this code dilation. See this. Now this is more of white and less of black. It turned the nearby pixels to 1 2. Can you see the difference? This is the original, this is erosion, this is dilation. Okay, now it is usually used on binary images because we can clearly see the difference and can clearly convert it into them, but I will also show you it on a non-binary image. We have a yay image here, yay. Okay, see this is the original, this is erosion, it is so big, and where is dilation? I wait a second, run it again. Okay, okay. You can't see the difference currently, right? You can't see it clearly, but I will show you one thing. Then you will see it. Now focus on this mobile. You see this numpad here and here. The original image. Now the erosion image is more darker color because it turned the pixels to black, and here we have a more bright color because it's dilation. Nice. You can try this out on any image. Search on internet and try. Okay.
दीदी वो 1 to 0 0 to 1 वाला कन्वर्जन एक बार फिर से बता दीजिए.
हाँ, ये था ना. सो सपोज ये मतलब कर्नल पे डिपेंड करता है. एक और चीज़ बताती हूँ इससे जो समझ आएगी. जैसे यहाँ मैंने 2 क्रॉस 2 मैट्रिक्स लिया था, है ना, और मेरा रिजल्ट आया था ये. Erosion, dilation, where is original? भाग गई. ठीक है. If I convert this to let's say 3 cross 3, ये 3x3 लेते हैं मैट्रिक्स, तो ये देखो ये ज़्यादा ही कम हो गया और ये ज़्यादा ही ज़्यादा हो गया तो मतलब वो मैट्रिक्स, इट डिपेंड्स ऑन द मैट्रिक्स यू आर यूजिंग। तो अब यहाँ से समझाती हूँ। कि मान लो 2x2 मैट्रिक्स लिया, यहाँ पे इसको बस 0 0 0 दिख रहा है, तो दिस इरोजन वॉन्ट डू एनीथिंग, ओके। इट मूव्स टू नेक्स्ट मैट्रिक्स 0 0 0, इट वॉन्ट सी एनीथिंग, इट वॉन्ट डू एनीथिंग। नेक्स्ट इट क्रॉस टू 2x2 मैट्रिक्स, इट सीज a 1, it will destroy that one and convert it into 0. So now we have more black thing. Like that it goes over full image, your full image, and the iteration. This iteration so shows the number of times it will go through the whole image. If I increase this iteration number to 2, it I will destroy. Iteration number 2. This also iteration number 2. So you see, चला ही गया image कहीं खाया। हाँ तो ये 1 ही रखते हैं, ठीक है। So now we can see the use of 3x3 iterations, ठीक है। And erosion dilation done. This is a sample image, this eroded to it and this dilated. Use, what is the use of erosion dilation? Let's suppose we have an image, this image, and let's suppose we have lot of noise in the background. We have white pixels, suppose, imagine we have lot of white pixels in the background. What if we want to clear those? So first we will do erosion, and what it will do, it will convert that into black. So we will have a clear image, but the size, here see you size decreased, but we don't want the decrease in size. So we will use this erosion image and convert it into dilation. So we will get the original size without the noise, right? इसका यूज हो गया, erosion dilation का यूज। Moving on to next topic, drawing on images in OpenCV. This is the simplest thing. You have an image, you want to draw a line on it, a circle, a rectangle, whatever. Like तुमने देखा होगा, you will see a face and there is a circle over it. How do they do it? So they do it using this. Code is basically line, cv2 dot line, the image we want to draw on, start point of that line, end point of that line, color of the line, and thickness. Similarly for rectangle and circle. Okay, I will show you code for this. Drawing. Okay, here I have this badi si image and this choti si line. So what was the code? Image, this is the image, cool image we drew a line on. Starting point is 0, 0, ending is 150. This color, like suppose you want a blue color, you can't simply write here blue and it will show you blue. No, right, you need to give the values, the RGB, BGR, HSV, whatever you want to give. Here you already know BGR is the default format, so we are putting the images in BGR. I haven't converted to HSV or anything, I am just putting this as in BGR. So I wanted a blue line, so I put it to 255, blue to 255, and G and R to 0 0. So I got a blue line and the thickness is 20. Okay.
Didi, I want to ask a question.
Yes.
If we will convert the image into if we will not convert the image into HSV and then we will give HSV code, the color code, then what will happen?
You have to write the HSV values here then. HSV.
Yes, but it will read as RGB, no?
No. You just converted the
No, I
image.
didn't convert. I'm saying if I don't convert into RGB, that means HSV, it is as
And
the
you
original.
write the HSV values.
Huh.
So it will take it as BGR values. It won't take it as
that's what
HSV values.
Okay.
The default is BGR, so it will take it as BGR.
And
Okay.
if I will convert it into HSV and I will give the HSV value, then it will give the output in HSV, no?
Means the output will be the original image, because
Okay.
that HSV is just converted to use the further functions. It is not on the original image. Output is going to be the original image, right?
Okay.
I have a rectangle.
जी हम लोग एंड पॉइंट कैसे निकाल लें?
एंड पॉइंट मैंने तो रैंडम रख दिया. यू कैन मतलब कैसे निकालोगे कि इमेज है, इमेज का साइज देखो. व्हाट इज द साइज ऑफ दिस इमेज? लाइक रियली बिग इमेज. तो 150 बहुत छोटा सा हो गया. तुम्हारा वो होता है ना 720 क्रॉस 720 या whatever, तो उसके हिसाब से यू कैन फाइंड आउट. 7 क्रॉस 20 है तो उसका मिड पॉइंट 360 होगा, तो 360 विल बी द मिड. तो उस मिड तक आप कर सकते हो लाइन ड्रॉ लाइक दैट. इसका ज़्यादा बड़ा है रेजोल्यूशन, 720 नहीं है इसका.
You can use the dot shape function to find the the correct means boundary point of the image. Then you can relatively scale your line.
एंड ये लाइक ऐसे भी कर सकते हो, लाइक फॉर एग्जांपल यू वांट कि कोई खुद से सिलेक्ट करना है बॉक्स एंड उस बॉक्स के कोऑर्डिनेट्स देखने इन द इमेज. सो देयर इज दिस फंक्शन कॉल्ड एज cv2.selectroi. लाइक आई हैव पुट इट इन द चैट. सो दैट यू कैन यूज, उसका कोड वील शेयर. सो यू बेसिकली यूज इट टू क्रिएट अ बाउंडिंग बॉक्स. जैसे सिलेक्ट करते हैं कोई भी चीज़ ना, सो यू यूज दैट एंड वो अपने आप कोऑर्डिनेट्स दे देगा तुम्हें. देन you can search it, this coordinate पे I want a line and this coordinate पे I want a line, so you just draw a line on that.
Okay, thank you.
Okay, so I have this code for rectangle. Can anyone guess the color it's going to show? Mute करके बोल दो, unmute.
Green.
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 वाओ कितने अच्छे बच्चे हैं. Green. ठीक है. And I decrease the thickness 10, तो थोड़ा ये पतला है, पतला green. Slim green. Yes. ठीक है. You can similarly draw for ellipse, polylines, anything. ठीक है. ये example. Now contours and moments. नहीं आया होगा समझ. तुषार समझाएगा. Passing on to तुषार.
Hello, am I audible?
Yes.
Are the slides visible?
Yeah. Busy.
Okay, so thank you, Shalini. Hello guys, I am Tushar Sarkar from Electrical Part 2, and now I'll be explaining you contours and movements. Okay, so first of all, let's begin with contours. So what are contours? Okay, so you can simply understand them as a curve joining all the continuous points along the boundary, having some the same color or intensity. Okay, so you can see in the below image. Okay, so when I converted the hand image to a binary image, so you can see that the hand has all the pixels are continuous with each other and have the same intensity, that is white, 255 255 255. Okay, so yeah, here so we use binary images to get better accuracy because you can identify the contours more clearly. Okay, yeah, so you can also see there are some noises in the left side of the binary image. That's what Shalini was talking about, which can be eroded. Okay, now if you try to find the contours in the image, in this binary image, you will find that there are several contours. One is this whole hand one, and other contours will be those small noises because they are also continuous. Okay, so yeah, basically finding contours is like finding white objects from black background. Yeah. So OpenCV uses a function dot find contours to find contours in OpenCV. Okay. So one second. So there are basically three arguments which are passed to dot find contours function. First is the source image, of course, and the second one is contour retrieval mode, and the third is contour approximation method. Okay. So I'll explain contour approximation method later. Now, yeah. Yeah, someone mic is on, I guess. Hello?
You can continue, Dushan.
Yeah, so what it outputs is it outputs basically two things: contours and hierarchy. Okay, so contour is a Python list of all the contours in the image. Okay, so it's basically a list of individual arrays which are for individual contours, and that array in turn contains an array of xy coordinates, which are the boundary points of that contour. So I'll try to explain it to you. One second. Yeah, 1 second, please. Uh, yeah, so here you can see like a contour will provide us with a array or a list of different arrays. Okay, so like if two contours are detected, okay, in an image, so we will get a list of two arrays. This array indeed will have xy points, okay, x comma y points, representing the boundary points of the object. Okay. Um, Now, yeah, contour approximation method. Okay, so basically the third argument. Let's show some code first. Is my screen visible here?
Yeah, screen is visible.
Okay, so yeah, I have written a demo code for contour here. Okay, so yeah, I've used this image. Okay, having these 5 shapes, and I've read it, then converted it to grayscale, and then I thresholded it with the thresholding value of 240. So I have used binary inverse. So what it does is it can anything above 240 will be converted to black, and anything below 240 will be converted to white. Okay, and then I've used the find contours function, giving the source image as thresh, and this is the contour retrieval mode, and this is the contour approximation method. Okay, so. um, So you can see this was the original image, and I converted it to grayscale, and then this was the thresholded after the thresholding. Okay, so and you can see I have printed here the length of contours. Okay, how many contours are detected? So there are 5 contours detected. Okay, so yeah, these are the 5 contours. Okay, now if I use thresh binary instead of inverse, then you will see that the number of contours detected here becomes 6. So any guesses what is the 6th contour here?
The outside contour, the whole, except the images.
Yeah, exactly. Actually, what it does is it whenever the background is white, no, so CV2 detects the whole image as a contour itself. Yeah, and then these triangle and these shapes are the inner boundaries of that white white contour. So that's why it detects 6 contours. Okay. Hmm. Wait a minute. Hmm. So I will parenting from here only. Okay. This is creating an issue. Yeah. So contour approximation method. So yeah, the third argument used is cv2.find contours. In cv2.find contours is the contour approximation method. Basically, I told you that in a contour, it basically stores all the boundary points. So maybe if we consider a regular shape like a square, rectangle, or triangle. Okay. So do we really need to store all the boundary points? Means even if I consider a line, okay, so if I know only the end point and the starting point of the line, don't I means know the whole line? Okay, so that is what contour approximation method does. Yeah, so there are basically two options. We have chain approx null and chain approx simple. So what chain approx null does is it means it stores all the boundary points. Okay, you can see this blue lines. So those are the boundary points, and all the boundary points are stored in chain approx null. And the chain approx simple approximation method removes all the redundant points and compresses the contour, storing only the points required to determine the shape. Okay, and yeah, this really reduces the size, okay, size of the contour and saves space. Yeah, and I didn't tell you about yeah. So yeah, hierarchy and retrieval mode are actually kind of related, and they are a little on the higher side for you guys now. So if you want to know more about those, you can see the OpenCV documentation, or else you can leave also. It will not falter your your preparation for this upcoming event. Yeah. So you can basically use RETR underscore tree or RETR underscore list for contour retrieval mode simply.
भैया एक सवाल पूछना था.
हाँ, go ahead.
That previous slide, please. No.
Yeah.
This slide. This you have written that contours, comma, hierarchy. Then we have to write it is variable, or we have to write this only fixed.
No, hierarchy is variable. It's not fixed. No. You
Okay, we can write
contours
C,
and hierarchy both
comma
have.
H also.
Yeah. Those are.
Or we can only write one variable, C is equal to CV2 dot.
No, you can't, because both variables are returned. So you can put a underscore sign, so that means it contain it takes the variable but doesn't utilizes it. Like I'll show in the code once more. Yeah. So explain you the contour approximation method. Yeah. So I'm taking this image. Okay, rectangle.png. And now I'll use binary only. And first, let me use chain approx null. So now I know that there will only be one contour detected. So now I'm printing, the number of points present in that contour. Okay. Let me comment this.
अरे वेट की कमेंट कर दिया.
Okay. Yeah. So here you can see 896. It's showing 896. So this, this figure, this rectangle has 896 points on, on the boundary. Okay. So all those points are being counted when I use chain approx null. And now if I use chain approx simple, so you will see, yeah, so only 4 points are considered in contour. Okay, now if I want to print those points, yeah, you can see these 4 points are the coordinates of the the corners of the rectangle. And how you can see that? You can see they are in the form of x1 comma y1, x1 comma y2, then y yeah, so x2 comma y2 and x2 comma y1. Okay, so you can recheck it. Okay, and now moving on. Yeah, so drawing contours. So basically, now we are, we are actually guessing. So what the contours would be? Yeah, like in those images, we know for sure that only 5 shapes are there. But in the real world, or when you solve some problems in the arena, sometimes the colors are actually, like different from each other. Okay, so not very different from each other actually. So you will not be able to differentiate the number of contours we obtained, okay, or those are the required contours or not. So we use the draw contour function to draw those contours, okay, the contours we have detected. So for that, the OpenCV uses dot draw contours function. We have basically 4 arguments. The source image contours is the a Python list which we pass so that the list contains all the contours that you want to draw. Okay, then the third argument is the index of the contours. Basically, if you want to draw a single contour, we detected maybe like 3 or 4 contours, and you want to draw a single contour, and you can input the the index of the contour you want to draw, and then CV2 will draw it. Or else, if you put pass in -1, then it will draw all the contours which are inside contours. Okay, and the last 2 arguments are the same, color and width of the line used. Okay, so you can see here when I pass -1, so all the contours were detected in the image, and when I pass say I want to draw the 4th contour, individual contour 4th, so I'm using 3 because the index starts from 0, so 0 1 2 3. Okay, so yeah, if this was the 3rd contour, then it would have been detected this.
भाई इंडेक्स कैसे पता चल रहा है?
इंडेक्स बेसिकली इंडेक्स जैसे अगर तुम प्रिंट करोगी लेंथ ऑफ कॉन्टूर्स, ओके, सो यू कैन फाइंड आउट कि कितने सारे कॉन्टूर्स डिटेक्ट हुए हैं, फिर उसमें से तुम कोई भी इंडेक्स मतलब पास ऑन कर सकती हो. सो
तो हम लोग को तो पता ही नहीं ना कितने हैं, तभी तो ड्रॉ कर रहे हैं.
या सो कितने कॉन्टूर्स है वो तुमको लेंथ ऑफ कॉन्टूर्स से पता चल जाएंगे. Like I use length of contours, so that will give you how many contours have been detected. Yeah, and then which contours are those. Okay, for that you can use individual index. Okay, like for example, if I detected contours, if I printed length of contours, okay, and it gave me 5, but I can see only 3. I want to know what are the other 2. So if I draw the contours, okay, with -1 argument, then I'll see all the 5 contours. And if I use any individual index, like if I have detected 5, then I can use 4 or 3 as an argument here. So I'll get to know which ones are those. Okay.
Okay.
And just to add on, by default, these contours are arranged in an order of increasing area. So your smallest contour will have the least index, so 0 will be assigned to the contour with the least area, and the highest index will belong to the contour with the most area. So in order to find the biggest area or the smallest area contour, you can refer to the particular index accordingly.
Okay.
Yeah. So for this actually to pass on, we do not prefer passing an individual index here. We instead what we do is we input the contours, the single contour in a variable, and then we pass on the variable inside a list in the draw contours function, and we use the index 0. Okay, so 0 because the list only has one contour, so it will print only that only. Okay. So I'll show you an example. Yeah, so here I'm using the contours image again. Yeah, so you can see I used thresh binary, so it detected these 5 and also it detected the whole image as a contour. Okay, you can see the green line, so it detected the whole image as a contour itself. Okay. So if I use minus inverse, so you will wait a minute. Yeah, you can see only these 5 contours are detected, and the whole image is not detected as a contour. Okay. Now to draw a particular contour. Yeah, so I passed on the argument to draw the 3rd contour. So this triangle was the 3rd contour in this image. So you can see it drew a contour, the lines on the boundary points. Okay. Now this is the second method. Yeah, so you can see the same thing occurs, but this is more efficient when you deal with a larger number of contours, and when you need to uh, do it in a loop or something like that. Okay, so this is preferred more. Okay, now yeah, so contour features. So what features does a contour have? Okay, a contour is basically a shape, so it would have area, perimeter, centroid, etc. Okay, and bounding boxes are like when we have irregular shape, so we do not draw along the boundary points. Okay, we do not draw the contour. Okay, we put a bounding box, a rectangle or something like that, to indicate that we have a contour present there. So what does movement mean? So basically in image processing, an image movement is a certain weighted average of the image pixel intensities. Okay, so it is basically used after once color segmentation and all are done, to find centroid of an image, or the object and the area of the object, etc. Okay. So I'll give you a basic intuition about movement. So you must have heard this word movement in physics in class 12th and 11th. Okay. So like moment of inertia and all. So what was it? Okay. So basically, what was it? It was basically an average of weights. Okay, around a particular axis or point, or something like that. Okay. So in CV2, the moment of ij is nothing but it's the overall sum of all the points, okay, in the image, with x raised to power I, y raised to power j, and here I is the intensity of image. But we are using binary image, so I of x comma y can only be 1 or 0. So basically it will take the coordinate values of the image, or the white image, or the contour, okay, to be specific. Okay, now if I take I as 1 and j as 0, so y to the power 0 will be always be 1. Okay, so basically what it does is it will sum over all the x coordinates of the image, the white image. Okay, uh, and then if I take I0 and j1, so it will take the sum over all the y values of the white image. Okay,
Bhaiya,
so
what is IJ?
ij basically it's actually defined like a movement of ij. It's defined like that only. Okay, to take different x's and y's. Okay, I'll explain it later, you will understand more clearly.
Okay.
So we use cv dot movements function in to find out the movement of a contour. Okay, we input a single contour inside the movements function, and that's the only argument it takes. And what it returns is, it returns a dictionary. Okay, so the Python dictionary, right? That it gives a key. It gives a key, and then it presents its value. Okay, so yeah. So yeah, this is basically ing. Okay, so mij, so m10 would give you the sum of all the x values of the white image. Yeah, and then m of 01 would give you all the y values of the image. Okay, then m00 you can guess. Okay, like if I keep the power 0, so x to power 0 and y to power 0 will always give 1, and then I am only adding 1 plus 1 plus 1 of the white image. So basically it gives the area. Okay, area of the, or the number of pixels present in the white region, or present in the contour. Okay, so yeah, this is the formula used to find the centroid of a contour. So Cx equals to anti of this m of bracket of m10 will give pass you the, you're passing the key which is m10, and it will return you the value which the moments function calculates. Okay, so I'll show you a demo. Huh. So yeah, so basically I'm taking the same contour. Yeah, some contour 3, that was the triangle one. Yeah, and inserting in movements, and then I am taking the coordinates. Yeah, this is the x coordinate, this is the y coordinate. Okay, and I'll print them, and I have used the cv2.circle function. I provided the image, and I've given the center coordinates as it is a centroid, so center coordinates will be 6 cx and cy, and then I have used the length. I have used the argument 3 to give radius, and then this is the color, and -1. Actually, -1, what it does is it will create a circle which is painted inside out. Okay, like uh, only not the color is not only in the boundary. Okay, the whole circle will be colored. Yeah, you can see here the red one. This is the centroid of the contour. Okay, and this is what I have printed here. You can also see the value of the cx and cy here printed over here in the terminal. Okay. Uh, Yeah, so moving on, to calculate the area of a contour, we have cv2 dot contour area function, or you can also use alternatively the moments we calculate m00. Okay, as defined earlier. So both are interchangeably can be interchangeably used. Okay, I'll show you a demo of this also. So you can see here, I have printed the areas. I have printed two areas. One was the area founded from cv2 dot contour area, and one m0 comma 0. Okay, so you can see both are the same. Both are the same things. Okay, so both can be interchangeably used. Yeah. Now moving on. So as I told you, bounding boxes. So if you want to a figure, you have a figure. Okay, but you don't want to draw the exact contours, but you want to bound that contour inside a rectangle. Okay, so what you will do? So basically we have two options. One is a straight rectangle and another one is rotated rectangle. Okay, so I'll show you the code and you'll understand. So uh, I'll take this image. Okay, so I've taken stars.jpg. Yeah, so yeah, I have the usual process, thresholding, and then I have founded contours. Okay, now this is the first method. So we use the dot bounding rectangle function to extract the bounding of here x and y would be the starting point, and w and h will be the width and height of the figure. Okay, then we use the cv2 dot rectangle function to um, show the image. Okay, or draw on the image basically. Yeah, you can see simply what it does is it just bounded the whole contour inside a straight rectangle. Okay, you can see this is not the minimum area of a rectangle. Okay, means it bounded the contour perfectly, but we can further reduce the area or further of the rectangle. So for that we use rotated rectangle. Yeah, so minimum area rectangle, basically what it does is it gives an output of the the coordinates of the rectangle, which will have the minimum area when surrounding all of the contour. Okay, so what it has a phi angle element, etc. Means additional. Okay, like here we were having x y w h, but here when dot min area rectangle is inserted, so we get an extra output, which is the angle. So we use the dot box points function to extract those, and then we basically draw contours. Okay, so you can see here I have inserted box inside an list because it is required. Yeah, so you can see here this is the minimum area rectangle use. Okay, Similarly, I can show you for another image. Yeah, you can see the whole rectangle is not visible because the image is small. Okay, but you can see this also took the minimum area. Okay. Yeah, now this is pretty similar to the rectangle function. What the rectangle function does is it surrounds the contour inside an rectangular bounding box. What bounding circle does is it encloses the figure or the contour inside a circumcircle of the object. Okay, it completely covers the object with minimum area possible. So let's show a quick demo of this also. Okay, I'm using the star.png. Uh, let's make this. Yeah, so you can see I provided the green color, that's why it's green color. Okay, so it bounds the whole contour. This is a circumcircle of the contour basically. Okay. Yeah, so yeah, CV2 uses the arc length function to give the perimeter of an contour. Okay, so yeah, there are two arguments basically. One is the the contour or the array of the contour. Okay, and the another is a boolean value. So what it does is it means it asks you whether to connect the last point and the first point or not. Okay, so if not connected, it would be an open curve, and if it is true, if we return true, pass on true, then it will connect the last point and the first point, and it will give a closed curve. I'll show you. Yeah, so here you can see the perimeter of the contour is presented. This one. Yeah. Mm, yeah, the perimeter of this triangle is printed here. Okay. Yeah. So now contour approximation. Okay. So what sometimes what happens uh, even after using the erosion dilution methods, your contour is still not coming perfect. Okay. So what to do? Means you have tried enough, but you are still not getting a perfect shape, and that's why you would not be you are not able to do the upholding tasks. Okay, so for this the OpenCV has a contour approximation method that we use. So what it does is basically is it changes the shape, not changes the shape, but it approximates the contour shape to another shape with a less number of vertices basically, depending on the precision. Okay, let's see. So yeah, dot approx poly dp function is used for this. Okay, it takes three arguments. Okay, first is the contour, the array contour array. The second is the epsilon, and the third is the true. True value is same for everything, that it connects the last point and the first point. Okay, and what is epsilon? So epsilon is the margin of error that we provide to the approximation function. Like if I want to approximate this, this image, you can see the center image, okay, or the rightmost image, okay. So the rightmost would be the perfect, arc length of the contour, but I think that there are some errors. Okay, I want to detect a rectangle, but I'm getting some errors in detecting the contour. So what to do? I will give epsilon, that is 0.1 into cv dot arc length. Okay, so arc length is the this perimeter only. Okay, and then I provide 0.1, that is 10% margin of error. So like if this in the center, if this lies inside the 10% range, then it will approximate this contour to this one. Okay, and approx will give these 4 boundary points instead of providing all these 1, 2, 3, 4, 5, 6, etc. Okay, so yeah, this is what the function of approx polynomial function is. Yeah, so you might think, what was the use of these all functions? Why to tell you these and bore you? But one of the fundamental tasks of computer processing, that is shape detection, can be done easily by these functions only. Okay, so yeah, shape detection is one of the fundamental elements of image processing. Okay, and we these all functions will come handy when we do the task. Okay? So this is a sample code of shape detection. I'll just show you the code now altogether. Yeah, so you can see these are the noises. Okay, these are the noises I'm talking about. You can see in these noises, and you want a perfect shape, but you're not getting one. So what to do? So I have provided here. You can see I have I have used find contours function to get the contour. Okay, and then I will use a 0.1 or 10% of margin of error, and then I'll try to print the contour. Okay. Okay, so I have not used stretch binary inverse. Yeah, so here you can see these all are approximated to a nearby shape, that nearby perfect shape, that is this one. Okay, now if contrary to it, like this one, or maybe this one. Okay, yeah, so yeah, sorry. So you need to pay attention to stretch binary and inverse also. Okay, uh, 1 second. Mm, maybe I use this example for now. Approximate. Yeah, you can see here it approximately it this error was neglected, and then it gives an approx shape of the contour. Okay, now I'll explain you the shape detection code. Okay, so I've used this image. This consists of 4 shapes. Okay, now you can see here that first I have converted it into grayscale, and then I have thresholded it with a value of 240, because these are very light pixels. Okay, light colors. Yeah, so yeah, then I have used dot find contours function to find contour. Okay, and I have used trust binary, so it will also detect the whole image as a contour itself. So I have, and it has the maximum area, so it will be detected for the first time. So yeah, that's why I have used this continue function. So if I equals to 1, then it will basically change I, and then continue the loop once again. Okay, so we will not get the output for the whole image. Now I have used the approx function here. Okay, I've used the value 0.01. Okay, I've kept the margin of error low, because for circle, if I'm detecting circle, it if I'm keeping this large, so it may happen that sometimes the circle is approximated to a square or something like that. Okay, so we do not want that to happen, so for that we generally keep this low. Okay, then I've used the CV2.draw contours. for and this function only. This would be, and then I've used the cv2.movements function to calculate the centroids x and y. Okay, and then yeah, length of approx. So what approx basically does is it has the coordinate points. Okay, so if I am approximating the contour, okay, for the first contour, like let's say for the square, okay, so I approximated it. So the approx function is also a list like a contour. Okay, so it would have let's say for the square, it would store 4 points. Okay, so when it has 4 points, we can now directly compare the length of approx function. Okay, so we know that a triangle has 3 sides or 3 corners to be exact. So approx function will have the 3 corners of a triangle. So if we have the length of approx as 3, so we can say that it is a triangle. If we have 4, so we can say that it is a quadrilateral. And if we don't get one of these above, and the third choice only leaves us with a circle when we are dealing with 3 shapes only. Okay, if I insert a pentagon and hexagon, let's say, so I will also keep elif of for equals to 5 and 6. Yeah, so you can see this was the original image, and this is the detected image. Yeah, so I have basically in the if else statements, I have basically you name them. Put text is used to write something on the image, and you can see the documentation and you will understand the arguments easily. Okay, so yeah, so I basically I use draw contour function to draw these, and also use the dot put text function to name them. Okay. So yeah, there's one more method you can use to for shape detection, and this works well for when you have symmetrical or um, regular shapes. Okay, so for example, there are some basic properties that equilateral triangle, squares, and circles have. Okay, so for an example, equilateral the area of equilateral triangle, the formula is √3/4 a square, and the perimeter will simply be 3a. So if I divide them both, area by perimeter square, so a square gets cancelled and I get a constant. Okay, so I can compare the cv2.contour area with sorry, I can compare the cv2.contour area by arc length ka whole square to a value nearby to this constant. Okay, means I will not exactly use equal to, but I'll provide a range so that uh, it has a margin of error. And then similarly you can do for a circle and square also, this method. Okay, because they also have this property. Okay, for circle you can use the radius, the property of radius and circle, the perimeter of the circle one. And for square you have similar to the area and perimeter only.